All right, let's go ahead and finish up the last three problems on solving trig equations number 2. These, again, if we look at the directions, are all about solving from 0 to 360. So all of our answers are going to be in degree measure, not radian measure. And I've already got Desmos up and running as my split screen here because I will be needing to use it at some point. All right, so I'm going to go ahead and zoom in on number 3 here. No, number 2. It has a 3 in it, but yeah, number 2. And immediately I see I've got a small problem because part of this problem is in terms of sine and part of the problem is in terms of cosine. It really doesn't matter which one you use to replace, but one of them needs to get replaced. So I'm going to go ahead and do it as, I'm going to go ahead and replace the cosine term with 1 minus sine squared theta. The left side didn't change. Let's go ahead and distribute on the right side. So that's going to be 6 minus 6 sine squared theta. I am going to take that negative 6 sine squared theta, move it over to the left side, and I'm going to take the 3 and move it over to the right side. So this is going to become, let's go ahead and just show it. So plus 6 sine squared theta here, plus 6 sine squared theta here, minus, that's a horrible 3, minus 3 minus 3. All right, so those terms are going to go. We're going to have 7 sine squared theta is equal to 3, which means sine squared theta is equal to 3 over 7. And at this point, I'm going to stop and take the square root of both sides. Now, I did screw this up in the last video a little bit by forgetting, and I remembered later within the same problem, but when we put a square root into the problem, we need to include a plus minus. Now, 3 over 7, I'm just going to let it be 3 over 7 underneath that radical, and I will let the calculator deal with it. All right? So we're going to do theta prime. So our reference angle is going to be the inverse sine of the square root. And I'm just going to pull the positive 3/7. We'll deal with the negative by looking at the quadrants, but let's just go ahead and have positive 3 over 7 underneath that radical and then figure out the inverse sine of that. So this little mess right here is going to go right into my calculator. So let's go ahead and grab the inverse sine of the square root of 3 over 7. And this is telling me that theta prime is 40.9 degrees. All right. So there's 2 answers here, right? We've got the positive sine value and we have the negative sine value. So graphically, if I were to draw this out, right, ASTC, let's deal with positive sine first. So sine is positive in quadrants 1 and 2. So if we look at just quadrant 1 and 2, in quadrant 1, we just use the reference angle. So theta is going to equal 40.9 degrees. That's straightforward. It is the reference angle. In quadrant 2, we're going to basically take 180 and subtract the reference angle, all right, because we want to back up off the x-axis, that 40.9 degrees. So that's going to put me at 139.1 degrees. Now, separately, let's take a look and say what happens when sine is negative. Well, sine is negative in quadrant 3 and quadrant 4. In quadrant 3, we're going to take 180 plus the reference angle, right? We want to push off the x-axis, that reference angle further. And then in quadrant 4, we want to pull back from a 360 by the reference angle. So those 2 answers, so 180 plus 40.9 is 220.9 degrees. And then 360 minus 40.9 would be 319.1 degrees. So 4 answers there. 2 of them are because sine can be positive in the first quadrant, sine can be positive in the second quadrant, and 2 of the answers are because sine is negative, right? We had a plus or minus. Sine is negative in quadrant 3 and quadrant 4. So 1 answer from each quadrant for that particular problem. All right, so that's number 2. Let's go ahead and slide on down to number 4 here. Now, the nice part about number 4 is everything is in terms of a single trig function, right? We have cosine squared y and a cosine y, so we don't have to worry about doing any translations. What we do need to worry about is factoring this thing. So let's go 5 cosine y, and that would be 2 cosine y. Let's see, 3 here, 1 there. What does that get me? 5, 6. All right, so that's plus minus. Now, you guys are kind of seeing me as I do the guess and check part of it. Guess and check is something I have done for years and years and years, so I am decently fast with it. If you can't guess and check, that is totally okay. Use whatever factoring method you can, including do U substitution to get the cosine completely out of the problem. All right, that is totally fine. So we've got 2 factors. I'm going to set the first factor. So 5 cosine y plus 3 equals 0. I just want to work with that one. I'll get to the other factor in a little bit. So this is going to be the cosine of y is equal to negative 3/5. So y prime is going to be the inverse cosine of just deal with the positive part. We'll take care of the negatives once we know the reference angle, and that's what that y prime is. So, oops, I forgot there's supposed to be an inverse sign there, or inverse cosine. All right, so speaking of inverse cosine, let's go ahead and grab the inverse cosine of 3/5. So y prime, my reference angle, is 53.1 degrees. So if I look at, and this is where I go visual, right, A, S, T, C. So this is supposed to be cosine at a negative. So where is cosine negative? Well, that's going to be second and third quadrants. So if I go with that, in the second quadrant here, I want to back up off the x-axis. So 180 minus the reference angle. That's going to be, let me come down here. So y is going to equal, what's 180 minus my reference angle? That's going to be 126.9 degrees. And then in quadrant 3, I'm going to push forward. So 180 plus the reference angle. There's a degree in there, or a decimal point in there. So 180 plus 53.1. So that's going to be 233.1 degrees. So that's what happens for this first factor, but we have a second factor that we want to get into. So second factor here, let's talk about, we've got 2 cosine y minus 1 is equal to 0. I'm going to go ahead and solve this. So cosine of y is equal to 1/2. Now, this is actually a place where you could absolutely use the calculator. I'll show you in a second what happens there. You might also just use your trig chart. So y prime here is going to be the inverse cosine of 1/2. Well, let's see what happens when I throw that into Desmos. So inverse cosine of 1/2. Oh, look, it's 60. So this is where you could actually use your trig chart. Pi over 3 and 60 degrees are the same thing. So if you use your trig chart, you would know it that way as well. So we have the reference angle. Let's go ahead and put the picture in place. A, S, T, C. Where is cosine positive? Well, cosine's going to be positive in quadrants 1 and 4. So in quadrant 1, you just use your reference angle. So that's going to be 60 degrees. And in quadrant 4, back up off the unit circle, right off that x-axis. So 360 minus the reference angle is just going to be 300 degrees. So 4 answers. 2 happen to be for your first factor set, and 2 of them are from the second factor set. So there's the work. Again, if factoring is not your strong suit in terms of factoring with guess and check, don't do it. Pick a different factoring method that works for you. All right, we have one more problem to get through here, and this is problem number 6. And of course, right, it's with factoring. We keep talking about it, and that's okay. So let's see what we got here. I'm going to need a 4 sine. Whoa, that I don't even know what that letter was. All right, 2 sine. Let's see, I need a 3 here, a 1 there. That's going to be a 12. Whoops, I signed those backwards. So it's going to be a negative and a positive equal to 0. Let me do a quick double check, and I'm good. Okay. Again, I know I factor, guess, and check pretty quickly. Do factoring however you know to. All right. So we are going to take each factor, set it equal to 0, and solve. So sine of x is equal to negative 1/4. So I'm going to do x prime is equal to the inverse sine of positive 1/4. I'll deal with the negatives with my quadrants. What I want to use is I want to get the reference angle here. So in Desmos, I'm going to go ahead and grab the inverse sine of 1/4, and that's, what is that, 14.5 degrees. So I have a reference angle. But visually, I want to look and see where is sine negative. So A, S, T, C. Sine is going to be negative in quadrants 3 and quadrant 4. All right, so we're not actually going to use the reference angle as an answer, but we're going to use it to find our answers. So quadrant 3, you're going to take 180 and push forward your reference angle. So 180 plus 14.5. So x equals 194.5 degrees. In quadrant 4, you're going to take and pull back 360 minus the reference angle. You're always using that reference angle to find your answers. So 360 minus 14.5 is going to be 345.5 degrees. So that takes care of our first factor. Let's take a look at our second factor. So, whoops, 2 sine, did I lose an x in that problem? I did. 2 sine of x. We don't need no x's. All right, there we go. So 2 sine x minus 3 equals 0, which means the sine of x is going to be 3/2. And I'm actually going to stop here. I will show you in a second in your calculator what's going to happen. I know this can't give me any answers, okay? So what's going on here, and this is the reminder, okay? 3/2 is greater than 1. So I'm just going to make a little note here. This is not possible for sine of x to equal a value outside of its range. And the range, what the heck was that word? Hold on a second. Range. The range for sine is from -1 to 1, right? That's its range. And I know that 3/2 is outside of that range. Now, if you don't remember that, or you don't even think about that as an option, if you just come up here and you follow the same steps, and you're like, oh, well, let's do x prime. All right, cool. So off to the side here, it doesn't matter. All right, so if I do x prime here, that would be the inverse sine of 3/2. Okay, now that's fine. Let's throw it in a calculator. So inverse sine of 3/2, your calculator is going to try and tell you that you're running into problems here. This is undefined. It doesn't make any sense mathematically. It's outside of the range, you know, whatever you want to remember about this. But basically, you can't do that. And because you can't get any answers for that part of the problem, that's okay. Just use the 2 answers that you do have already, and there you go. We have solved for x. So if one of your functions, if one of your terms is outside of the range for either sine or cosine, that's all right. As long as you've done your factoring correctly, you're good to go. All right. So that's the end of this particular video. Let me know if you have any questions or concerns on solving these problems using degree.